Dr. Gold in the lab, Twitch stream glowing, formulas flashing, minds wide, knowledge flowing, equations on the board, numbers never sleep, teaching math and physics while them haters count sheep. Actual education, tune in and get schooled, flipping textbooks, breaking all the rules, from Newton to Einstein, concepts elevate. Keep the stream, it's the key to our fate. Dr. Gold dropping gems, knowledge raining down, actual education making scholars all around. Perpendicular minds, angles sharp as ice, maths and physics, yeah, the future's real nice. Got the Pythagorean triangles about to flex, quantum theories on deck, breaking all the specs, relativity theories, worlds getting small, grasp the universal laws, standing tall. From the atom to the cosmos, we rolling deep, grazing up the stars, no time to sleep. Black holes and supernovas, concepts we unfold, brain power heavy, yeah, that's Dr. Gold. Dr. Gold dropping gems, knowledge raining down, actual education making scholars all around. Perpendicular minds, angles sharp as ice, maths and physics, yeah, the future's real nice.
All right, what's up, everybody? Live. Boom, 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 ba-da-dum. It is. What? It is. Dude, I have a stream today. Excuse me. Whatever. Office hours. I think sometimes if I start it too early, it doesn't know that we have a stream. Ooh, I gotta, one second, let me cast this. Oh no, that didn't, there we go, that's what I want. What's up, Millie? What's up, X-Man? My guy.
Nice.
All right. Yes, today is Thursday.
My man.
Super fun. One more day left in the week, and then I think next week is gonna be our last week of streaming for the year. But I hope you guys are doing well. Had a science test. I can't speak today.
No.
Had a science test today on 8th grade physics. Was pretty chill. I'm glad it was chill. Nice. Love that.
Nice.
My day's been like pretty intense. And it's because it's finals weekend. A lot of the private students I tutor are just like mobbing me this week and next week because they have final exams this week, and then I think the last ones are next week, and then I'm done. Yeah, it's a lot of, like, today, what did I teach today? I taught computer architecture, also taught logic, and then tonight I think I'm going to teach calculus. So, yeah, and it's just because it's finals. But it's a good time to just kind of, like, lock in and try to, take advantage of the fact that everyone needs help now, because nobody needs help in a week. Or like January either, dude. Oh my god, January is such a dead zone. It's a dead month if you're trying to be a tutor. No one really needs help in January. Luckily though, I signed with another company, so doing some fun AI education development stuff. So that's what I'm probably going to occupy most of my time that I would be private tutoring with when the year starts. But glad to see all you guys. Hope the month of December is treating you guys well. Hope all the finals are going well. Laz, hope all your college apps are going great. I saw you were submitting to Princeton. It's a great place. I was there once, actually. I was in Princeton. Very long time ago. I probably got a picture of myself. You want to see when I was in Princeton? It was for what was it for? Oh, it was for a research fellowship thing I had. Oh wow, wait a minute. I don't even know if I have pictures from this. This is before I had Google Photos. Oh man. Yeah, this is like 20. What's my Facebook password? God damn it.
You done messed up, AA.
Oh, I don't really want to load my Facebook password. It's so long. Did I get it right? Ooh, I did. Nice.
Good job.
Okay. My password is like probably like 60 characters or something. Let me find the photo for you guys. Well, back before two-factor authentication, that was the way to make sure your account was secure. Was to just put like a ridiculous number of characters in your password. Albums. Let's see. When was it? It was Princeton. When was Princeton? Princeton was 2011, I think. Man, when was Princeton? There we go. Here we go. Here's the album. Princeton. I found it. Long lost folders. Princeton. Yes, here we go. There's probably a nice group photo of all of us at some point. But yeah, this was super cool. This is Princeton is very well known for its plasma laboratories. And so this is plasma, by the way. All the way from 2010. This is from what, 15 years ago? This is a cool stellarator, I think is what this is. Yeah. Look how low res these photos are too. Where's the photo? There we go. This is the photo of all of us. This was my cohort. Let me see if I can like zoom in at all. Very pretty campus, Princeton, by the way. It's very like old schooly. They got like dining halls and stuff. It looks beautiful. Except like none of the rooms. This was my dorm room that I had. Very bare bones. No air conditioning too, and it was in the summer. Your bed was made with care by member of the Princeton. Like, why is the band making our beds? I'm trying to see. Why can I not like? I want to look at this photo. Can I just look at this photo? Google. Oh, here you go. Here's. Oh no, of course it's not found because they took it down. Anyways, yeah, this was like a summer internship I had. So I talk about these a lot. These are called REUs, Research Experience for Undergraduates. So if you're looking to get involved with it, this is mainly for if you're in college. If you want to go to grad school, a very good way to get into a good graduate school is to show the school you're applying to that you know how to do research. And how do you get research experience? There's literally a program for it. It's called Research Experience for Undergraduates, REU. And it's funded by the NSF, which is the big thing in the US. So you can, I think they usually have like a search for thing, like search. This is, where is it? There you go. Here's like past, do they still do this? I hope they still do this. I don't know. Oh, maybe not. This website's kind of old. Oh shit. Let me type in like REU. There you go. Okay, this is at least from 2024. So they will probably put something out in the next couple days. Yeah. Without one of my faculty recommenders being a Princeton PhD and recommending apply to Princeton, I wouldn't know what they actually do a lot of stuff in my research interests. At this time, I was thinking about Princeton as a place to study music without going to conservatory.
Good job.
I mean, you probably can. Where do they have... Where's like how to apply? Why do they make this so difficult? Solicitation. Okay, I don't know. They make things hard, but okay. REUs are one way to do things. Or maybe this is it. Here, search. Okay, search the REU sites. There we go. This is what I wanted. Here, I'll post this link in the chat for you guys. There you go. But if you're thinking about getting involved in research, which is what you have to do if you want to do a PhD or any sort of higher level education, this is a great way to get research during your undergraduate. So, like, for instance, let's say, Laz, what are you interested in? Like material sciences, right? Material sciences. There you go. Here we go. Material Sciences Center. So this one has one. So apparently, yeah, they have a REU program. Well, page doesn't work. Okay, Northwestern. Page not found. Oh, man, dude. MIT? There we go. Okay, there you go. There you go. Oh, wait. Will not be running until further notice. Okay, well, fuck. Harvard. There we go. Okay, cool. They talk about it, but like, how do you get into these things? Maybe email. At least they give you contacts here. So this would be a good idea to just like email these people and say like, hey, do you guys have any research experiences that you guys are doing? Because they're paid. At least mine was. I bought a motorcycle with the money they gave me. There you go. After 85-year search, massless particles with promise of next generation electronics were discovered. Nice. Yeah. Fermions. Wow, this is all cool. A lot of stuff going on here. This shit is kind of cooked. Yeah, unfortunately, I think a lot of funding got cut in the last year or two to like the traditional things that would be available for people. Thanks, Trump. But that's not to say that these things don't still exist in some regard. You just have to try a little harder, I guess, to find them. But REUs are good. The other one was called Sully Undergraduate Research. Yeah, OSTI. I wonder if this is still funded. Oh, here we go. Here we go. The Science Undergraduate Laboratory Internships is open for the summer 2026 term. Applications are due January 7th. Access to the application center is due here. Perfect. This is... Okay, I guess you have to create an account. But this is still open. Okay. I think REUs might have lost a little bit of funding. Because that was under NSF, and NSF got absolutely fucked. But the DOE, Department of Energy, DOE, still has money. So... These people. Nice. So yeah, go check this out. Go apply if you're an undergraduate and you want to like get involved in research. All sorts of research, by the way, too. It's not just like physics. Like they have math stuff, they have chemistry stuff, they have so many different things. And yeah, benefits. I'm pretty sure you get paid. Yeah, you get a stipend. Weekly stipend of $650. Nice. And you get housing support. Yeah, usually like either the lab will give you housing or one of the researchers at the lab will like be willing to let you stay at their house. So these are really cool. And yeah, they give you a flight. Yeah, so they'll fly you out. So I flew out to Los Alamos is where I did my REU at. That's cool. $650 a week. Yeah, that's what? Like that's enough to eat at least. Better than food stamps. But the main thing is like you get experience, and this is the thing that is invaluable, and you can't purchase this. Having this on a resume, having a letter of recommendation from someone at a major lab that you worked with, all of these things will help you out immensely if you're applying for PhD programs. So, the fact you're getting paid is awesome. Some people like end up paying to try to do these types of things. 10 weeks, yeah, nice. So $6,500. Sulis and serfs are typically limited to U.S. citizens. Oh, yeah, that's probably another thing. Sorry, Laz. So yeah. Most things require you to be a citizen of the United States. But look at your country, see if they have similar things. Yeah, internships at the White House, you have to pay. Right, because there's so much demand for it. Anyways, okay, cool. So yeah, today will be the last stream of the week. We don't have a stream tomorrow. But I am looking forward to seeing you guys on Sunday to prep for like the last final exams coming up next week. And then after that, we're gonna do a lot of just like fun like video game streams. We'll do a chess tournament or something. What's up, Alistair? I might do like a little Santa giveaway thing. We did it one year. It was really fun. I was in like a gold Santa suit. I wonder if I have it here in my channel. One second, let me go find it real quick. Did we do it? It was like Chris Santa. No, slanted. There, this was it. I did this in 2023. I did an end of the year. Well, we did like a fun little survey. And I dressed up in a gold Santa suit, and I just gave out prizes and stuff. So yeah, it was fun. We might do this again this year because this was a lot of fun. All right, looks like we got questions. Let's start off the stream, get you guys some help, and kick things off. All right, welcome to everyone to Office Hours. My name's Dr. Gold, Besides Education.
Good job.
Stream that helps you with math homework, science homework, all sorts of fun stuff happening today. Mind if I speak? You're not busy? Well, I'm getting busy now. You can always text. You can always text things. Yes, if you want to help out with a question, yes, totally. I always accept help for questions. First question is up from Millie. And here, let me make sure our chats are all working. One sec. Yep, that one's up. Let's connect to TikTok. TikTok's always being a pain. But I think it's working now. Boom, boom, boom. Boom, 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 boom. Yeah, this was some spherical coordinate stuff we were doing. I kind of need, let me see, actualdiscord.com. Let's see what we got. Live queue. Millie! Okay. What do they want us to do with this, Millie? Find out whether it converges or not? Yeah, okay. I think you can say it converges by the alternating series test, right? Because sine of n is bounded by -1 to 1. Oh, I guess you have to show if it distinctly oscillates though, right? Because it doesn't do plus minus plus minus plus minus, unfortunately, right?
No.
Okay. But okay, just taking this thing into account first. All right, let's say for instance, bagel. What's up, JC? It's National Bagel Day. I do like bagels. I should have talked about bagels. So sine of n over n squared. Let's think just about sine of n first of all. So sine of n has to be somewhere between -1 and 1. Yep, exactly. I got it, Jeff. So that's true. So then this over n squared, over n squared, over n squared, I guess, right? So at least I show that the last term goes to 0. I know that. This is actually a beautiful example of the squeeze theorem, right? Because if you take the limit as n approaches infinity, -1 over infinity is 0. 1 over infinity is also 0. Thank you, Trollcats. Always appreciate you, bro. 1 over infinity is also 0. And since this is greater than or equal to 0 and less than or equal to 0, it's basically also equal to 0.
Perfect.
But that doesn't prove convergence. That just proves that the last term goes to 0, which means at least it doesn't diverge. Or we can't say that it diverges. I think I want to use the limit comparison test here though, right? Because what I do know, right, is that the absolute value of sine of n. Integral test, Alistair says. I don't think I want to do that one. I guess I could with integration by parts, maybe. Right, exactly. So sine of n, the absolute value of sine of n, has to be less than or equal to 1. And thus, this over n squared has to be less than or equal to 1 over n squared. So the summation from, like, let's say from n equals 1 to infinity of this has to be less than or equal to the summation of this. And this is very well known. Nice. Good luck with the trumpet practice, dude. Water polo, that sounds dope.
That's dope.
Okay. We know this converges. Do they say this is by the p-test? What do we call p-test? Is it called p-test or something? Where do you submit your homework? Actualofficehours.com. Website down there. Or P-Series, I think. Is it P-Series? Yes, this one. It's called the P-Series. Yeah, the P-Series test. Okay, so we know this. Not the P-test. The P-test is for, like, stats. By P-Series. Okay. Yeah, no, we'll definitely get to it. Because the queue is exactly 0 questions right now. If you submit your question right now, it'll be the next question we do. The queue is quite light today. Is your stream recording? Yes, my stream always records. It's always either on YouTube or it's on Twitch. Okay, so this converges. So this must converge. So that means, since the absolute value of n equals 2, and also if n equals 1 converges, n equals 2 converges as well, right? Just starts at a later time. Of -1 to the n minus 2 sine of n over n squared converges. Now, I believe this is this absolute convergence is what we say? No, it's asking just if it converges, JC. I gotta remember, like, absolute versus conditional. Yeah, okay. So if the absolute value converges... Oh, but if they go to 2 different things, then it's conditional convergence. Oh. Oh, interesting. So it can't be conditional, right? Because, yeah, this is absolutely convergent. Oh, I remember now. Yeah, so actually the absolute value is like the superior one. Sorry, the D means diverges. Yeah, sorry, that's what I meant. Yeah. Okay, thank you. So this is the key thing. So the absolute value converges, which means that the one that's not absolute value also converges. So yeah, I think you can just say converges absolutely. What message? What message did you say, JC? There's the chat so far. What message did you say? I guess the reason being, so what absolute value does, right, is that, like, gets rid of this. Like, because I don't really care about the oscillating -1 part. And then it just becomes the absolute value of sine of n over n. And then absolute value of sine over n, sine n is always less than or equal to 1. And then so over n squared, you know this converges. This is always less than this, so it must also converge. So I think you can just say it converges absolutely, Millie. It's actually not it's not a hard one. Just I think we call this, like, the comparison test. We did this by, this was P-Series. You have a hardish parametric equation? Cool. Okay. Nice. I think this is good. It's a lot easier than the question you gave us yesterday, Millie. I was getting kind of scared. I was like, oh no. Am I going to need Norosky to show up? Norosky's going to have to save me on, like, the harder math. Cool. All right, let's see. Let's mark that question as done. Nice, Millie. Cool. Those summations are killing me, yeah. All right, let's see what we got next. So again, if you want to submit a question, website's actualofficehours.com. You should see this website, and then you can put your username in, drop in a screenshot, and hit submit. Moss said, hey, I just want to say I love your streams. It became a routine for me. Fuck yeah, dude. That's dope.
That's dope.
EON Fitness says, integrate tangent squared from 0 to infinity? Isn't that just infinite? Right? Or wait, isn't that just 0? Wait, tangent squared. Yeah, that's infinity. What? It's gotta be infinity. Tangent squared? Well, because then tangent's just always positive. Tangent is a cyclic, or what do we call it? The question's in Norwegian. Is this in Norwegian? Oh, you can submit it. Like I can translate. I can translate with Google. Not Google. Sorry, with ChatGPT. This was kind of a series. It wasn't a power series though. Let's see what the next question's a physics question. Strongman competitions. I feel like sometimes I'm training to be a strongman person, because I just like lift really heavy weights and just eat whatever. I've gained like 30 pounds in the last 3 months.
Oh shit, not good.
I'd say half of it is muscle. Half of it is I just like eat cookies. Okay. In one particular event, a competitor must drag a cement block across a rough floor using a rope. When the object is moving, the frictional force is proportional to the normal reaction. The frictional force is proportional to the normal reaction force of the object? Oh, okay, this is just the normal force. Reaction force, I guess they're talking about, that's the force between the object and the ground, right? This is Fn. Right? Because then something is being pulled. So it's like a pulling force. And then you have friction. Bryson, just ace Diffie Q final. Feeling dangerous.
That's dope.
Good job. Yeah, I know. Everyone's taking finals right now. Great job on your finals, though, if you're acing it. The competitor must drag a 200 kilogram block across a rough surface. In the second round, they have to drag a 280 kilogram block. The force exerted by the competitor in round 2 is 1650. Calculate the difference in the frictional forces between the first and second rounds when the blocks are in motion. You may assume that the block moves with constant speed and air resistance can be ignored. Okay, so this is a key thing. So constant speed means acceleration is equal to 0. And the sum of the forces in the x direction, which in this case is Fp minus Fs, or I guess Fk, sorry, it's kinetic friction, right? Yeah. S is usually like static friction, K. That equals ma, but acceleration is 0. Right? So, since this is 0, you just get that Fp equals Fk. We are, dude. We are radiant, dude. Radiant strength, dude. Is this your question, dude? We're talking about strongman competitions. Your strength is radiant. Okay. Cool. Calculate the difference in the frictional forces when the blocks are in motion. So, the other cool thing about friction. So, friction is always equal to mu k Fn. All right? Mu k is the coefficient of friction. And the normal force, Fn, that's the force that the ground exerts upwards on the object, which in the case of something just moving left and right and there's no additional up-down forces happening besides gravity, usually force of gravity equals normal force. So we can just say this is equal to mu k Fg, and the force of gravity is equal to mg. Okay. So let's talk about like situation 1, right? Which is the light block. This is the block that is only 200 kilograms. Okay. So you have that pulling force in situation 1 is equal to the force of friction in situation 1. But the force of friction in situation 1 is going to be equal to mu k m1g. And we don't know what the pushing force is now yet. Okay. Situation 2. Pulling force the second time, which we do know what that is, right? The force exerted by the competitor in round 2, that's 1650. This is going to be equal to mu k m2g. If the strongman pulled at an angle, could they decrease the effective mass and thus the friction? Yes. So this is a great question. If they pull upwards, you're right. What happens is you start decreasing the normal force because the amount of force needed to oppose gravity pulling this block like towards China is less because you also have pulling force pulling up. But the problem here, Jeff, is that you also decrease the amount of force pulling against friction. So you are correct that frictional force would go down, but then also the amount of force that you're applying to fight friction goes down. And I don't think there's an advantage. I don't think there's an optimal angle, right? Because if you were to look at it, right? So, sorry, if we were to do this, all right? So Fn, let's say this is up at an angle. You would say Fn plus Fp sine theta is equal to mg, right? So the normal force up, the amount of your pulling force up has to be equal to mg. So Fn is equal to mg minus Fp sine theta. So then friction would be equal to mu k mg minus Fp sine theta. And then the amount of force you would need to fight that friction would be your pulling force, but your pulling force would now be Fp cosine theta. Exactly, right. So I guess the question here, yeah, Radiant says the higher the angle, the higher the ratio of the dynamic force needed to make it move. Yeah. Yes. This is correct. This could be thought of as the amount of force needed to break it from moving. Because when the two forces equal each other, and then this is, for instance, like mu s, that's like the braking force, right? What makes this 0? What do you mean? What makes what 0? What makes the angle 0? So actually, okay, so, yeah, let's not do the equals. Let's just say force of friction is this. Okay, so then let's talk about the acceleration of the object, because that's really what matters, right? Is like, how fast can you pull it? So ma would be equal to Fp cosine theta minus mu k mg minus Fp sine theta, right? So in the case that the angle is 0, right, then this is equal to 1. How does the required static force change as the angle increases? So, in order to break static friction, first of all, this would be mu s, and this would be mg minus Fp sine theta. Now this has to equal to Fp cosine theta. True, constant speed. So maybe, Jeff, are you asking, do you need less of a force to pull it at a constant speed? Like, so this for instance, here, this says, this is braking static. And this is moving with constant velocity. Right, assume the weak strongman with with minimal pulling force. Okay. So that's this then, right? So in that case, right? You want to solve for FP then, maybe? As a function of theta, just to see if there's like a max. I mean, I guess we could do this, right? Okay, cool. I think that's valid. You just change mu k and mu s if it's the break. Okay, so mu k mg minus mu k sine theta fp equals fp cosine theta. So move that over. Mu k mg is equal to fp. This is cosine theta plus mu k sine theta, right? And then blah 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 blah. Okay, so fp is equal to mu k mg over cosine theta plus mu k sine theta. This is physics. We kind of went on a tangent. Sorry, look, I should solve the original question. Jeff put me on a tangent of like, hey, what happens with different angles? Right. So for which theta is this minimal? Yeah, we could take the derivative, I guess, with respect to theta. Learning more is better. Okay, legendary. All right, great. Okay. So, all right. So fp is equal to mu k mg, and then this is going to be times -1, and then this will be cosine theta plus mu k sine theta to the -2, and then times the derivative of that, which will be negative sine theta plus mu k cosine theta. Okay. And we want to set that equal to 0. Okay. So, sorry, this is df d theta. So this is 0. It's a little ugly. But the nice thing is if this is equal to 0, and we assume that mu k mg and all this shit's not equal to 0, that just goes away. So, I just get, what is this? Mu k cosine theta minus sine theta. Over mu k cosine theta. Sorry. Mu k sine theta plus cosine theta squared. Femvox says tangent of theta is equal to mu k. Is it? Where do we get that from, Fem? Denominator can't be 0. Sorry, what am I... Yeah, no. This is okay. This has to equal 0. Okay, so you just need this to equal to... Oh, yes. Yes. In order this to equal to 0, this just has to equal 0. Yes. Got you. Sine theta equals mu k cosine theta. Beautiful. Yes. Sine over cosine equals mu k. So, tangent of theta equals mu k. So, theta equals the arctan of mu k. Is that right? So smart, less strongman pulls upwards at an angle of arctangent of the coefficient of friction. I guess so. It's actually pretty cool. And then, well, that's where it's a max or a min, though. Sorry. That's not where it's minimized, necessarily. That's where it's a max or a min. So, technically, yeah, no, technically we gotta take a second derivative.
That's dope.
Let's just graph this. Can we just graph this? Yeah, no, I think the border condition is I think 0 is the most efficient way to do this. But here, let's pull up Desmos. Where's my graphing calculator? Okay, and then let's just graph. I don't really need the mu KMG, right? Or I guess I do. What was it? Okay. Let's just graph mu KMG. Let's just graph 1 over cosine theta plus sine theta, right? No, I do kind of have to. I do need to like put in values for this, don't I? Kind of. No, but they're constants. These are all constants at the end of the day. But fuck, we still got a mu k in there. Yes, I like that, Fem. Yeah, Fem's got it. Yeah, we do. We need mu k in there at least. Yeah. Or let's say cosine of x, right? Plus a times sine of x. Add a slider. Okay, cool. And a is usually... And then, let's think. The angle can only be between 0 and 90. So let's set some bounds, right? Where is it here? So x-axis can only go from 0 to pi over 2, right? Yeah. Okay. And you can't have negative force. Oh, wait, but a can't be negative 0.9. Yeah, there we go. Okay. Interesting. Oh, you need the mg and the mu k to be values. Yes, but on the top, it's positive, right? It's just a positive constant. Friction is a negative force? No, but we're looking at FP. FP has to be positive, no? Mu k can't be 0, right? Mu k can only be like... Yeah, mu k is usually between 0 and 1. I don't think you can have something that's like greater. Can you have mu k's that are greater than 1? Okay, so in any case, yeah, it looks like it's a minimum actually. Like let's assume like this is equal to 0.5, right? Then the minimum should occur at the arctangent of 0.5. What's the arctangent of a half? It's 0.46. Yeah, so that's probably the minimum. $30 degrees, yeah. Wait. Yeah, no, yeah, it's not 30 degrees. That'd be like the arc sine. Okay, so if mu k is equal to a half, which is a pretty standard mu k, then you would expect the minimum force to happen at 26 degrees. Okay. Because that does look like a minimum, right? Yeah. I don't think the minimum's at 0, right? 0, 1. There you go. Yeah, it finds it. Yep, yeah, there we go. I think Desmo's pretty smart, right? It finds the minimums for you. Very cool. Nice. Okay, cool. Yes. Yeah, and obviously it blows up at 90 degrees. Yeah, because then you need infinite force. Yeah, okay. Cool. All right, that's actually pretty cool.
Oh, yeah.
Okay. I didn't know that. I learned something new today. Thanks, Jeff, for the inspiration. Let's do this one real quick, though. Let me actually, solve this. M2 is 2... So here, M equals 280. Here, M equals 200. Well, it was actually really fun. I've actually also wondered that, though, right? Okay. So, here we go. So, FP1 is equal to mu k 200 G. FP2 is 1650 is equal to mu k times 280G. So I think from this you can solve for mu k, right? And then from mu k we can then figure out the force for the first one. So from this, you get mu k is equal to 1650 over 280 times 9.8. Let's see what that is as a number. Okay, pull it up. Also, dude, TikTok, fix your chat client, dude. It's so bad. What's up, Machka? Okay. So let's pull up the calculator. So 1650 divided by 280 divided by 9.8 gives me a mu k 0.6 about. Okay. Good. Yep, I agree. Legendary. And then we're going to take that and plug that into here to figure out what the pushing force for FP1, which is the frictional force under the first block too. Gunner says, I just failed my Diffie Q exam. Oh no.
Disqualified.
Can I have words of advice? It's never over. Yeah. What's the famous quote there? It's not the end if it's over, it's not the end, and if it's over, it's not. If it's the end, it's not over. It ain't over till my ex-wife sings. No. Oh, I can't remember it. Basically, yeah, no. Take the experience. Try to like look back at like what you could have done better. Like, did you need more time to study? Could you have like slept better the night before? Did you not do the homeworks? Stuff like that. And then just retake it. That's okay. Yes. Gunner the drummer. Yeah. Like, yeah. It's not the end of the world. Yeah. I always bring up the great example of my my college roommate, my first college roommate. His name's Matt. He failed calculus like 3 times. He just like couldn't get it. Just kept failing calculus, but he eventually passed it the 4th time. And now that guy makes like $400,000 like studying like chemical plastics. So don't worry. Just because you fail one class doesn't mean you can't later be successful in life. If you keep failing classes and not like adjusting your behavior to stop failing classes, then yes, then you won't have a great time. But everything's a learning experience. That's what I say. So take it as a learning experience. Nice. Okay, so this is 1179 newtons. And then they want the difference, right, in the frictional forces. So you just do 1650 minus that. $1650 minus 1179, and that's going to get you 471 newtons, and you're done. Good job.
That's
Nice, cool. This is a lot of fun. A lot of red here. It gives me anxiety to use 9 point. Dude, some teachers use 10. They seriously use 10. Some teachers use 10. Be lucky that I'm using 9.8. Legendary, dude. Nice. Okay, good question, Pro. I liked the discussion follow-up by Jeff as well. It was fun. Nice. Legendary. What? Do you have a name in our Discord, by the way, Legendary? I want to give you credit in our Discord. How long is the queue? 6 questions so far. Not too bad. Not too bad. Sorry, let me. I want TikTok to work. I would like my TikTok chat to work. There we go. Jesus, there's all of them. Fresco says, took my thermo final. It was cooked. Better than the modern final. Average of 12. Dude, 12 out of 50? Dude, what a 24? That's terrible. Yes, pi equals e equals 3 and somehow still pass. Yeah. Yeah. Those are the engineering people. We don't speak about those people. Alright, River. Wait, what's your question, River? What is this? What do you want me to do with this? As a function? What do you mean as a function? I see 2 coordinates. It's parametric. I don't know what that means. Parametric usually means that there's a parameter. Oh, n is the parameter? Wait. The first is a Fourier series, the second is a geometric series. For the second, factor sine of t out. Ooh, yeah, because sine doesn't depend on n. And t is the parameter. I can't factor it out of the first one, though, no? Thanks for the roses dot, by the way. Okay. Send me River what you mean by that. This is from Bob. Thanks, Cultivate. Is this like an engineering question again? Someone got me physics. Okay. Disc is made from a thin card, radius, and pinned to the board so it hangs vertically in equilibrium. 3 forces act on the plane of the disc. 2 forces act tangentially on the circumference with a magnitude F1. Another one acts at a point halfway between the pin and the edge. Oh, so there's another point here. Okay, great. Okay. Find the force F2 in terms of... Express the force F2 in terms of F1. Francesco says, read me above, please. We do have a lot of engineering. This isn't really an engineering question, though, is it? This is kind of a physics question. Femvox got F2 is equal to 8 F1. Let's see why that is. Wait, does F2... Wait. Another point acts at a halfway between the pin and the edge at an angle of 30 degrees from the radial line. Are you just doing sum of torques? Because, yeah, I'm wondering, like, what this angle is. If I want to do, like... Well, I guess this force balances with this force... Wait, but how's that going to work? Yeah, sum of torques? Okay, cool. Oh, I see. There must be a force on the pin pulling it up then. Okay. Because I was looking at this. I'm like, wait a minute. How does this and this balance, but then this, like, somehow doesn't keep it down? No. It's because there's a force on the pin up. Okay, cool. So this is sum of torques. Yeah, sum of forces in the X and the Y direction would work, but then I need to know more information about this, right? I'd have to know what this angle is. Okay. Well, these two torques both act in the same direction, right? So sum of torques. You guys like this for torque. Has to be equal to 0. So these two have, so torque, I say is like equal to R perp F or RF perp. So it's like either the amount of radius perpendicular to the force or the amount of force perpendicular to the radius. So in this case, we could say like torque 1. And torque is positive. It's in the counterclockwise direction. That's going to be equal to RF1. And then you have two of those, right? So sum of torques is going to equal to 2RF1 plus this torque. And this torque is negative because this torque is causing it to be counterclockwise. Okay, so we can put a minus sign here. And then looking here, this R is going to be 1/2. And then the amount of force that's perpendicular to R, that's actually pretty cool. So if this is 30 degrees, right? This force has two components. It has what I would call like F parallel, because that's parallel to R. And then it also has F perp. This is F perp. Because this is the component of the force which is perpendicular to the radius. And that's going to be equal to F2. If this is 30 degrees, that's opposite. That's sine 30. And y'all should know the sine of 30 degrees is just 1/2. Okay. So that's equal to 1/2 F2. Okay. So now we can plug that in here. So this was 1/2 R, because that was the radius, times 1/2 F2. And this all is equal to 0. Cool. Alright, so I have 2RF1 minus 1/4 RF2 equals 0. I can cancel the R's. That's nice. Goodbye, goodbye. And then if you just move this over to the other side, you get 1/4 F2 equals 2F1. Just move that over. F2 equals 8F1, which is what Fembox got. So nice. Great job. Yeah, it's in rotational equilibrium too, I think is what they said. Because they said it's hanging vertically in equilibrium. Max, right? Nice. Okay, cool. Great question. That was from Bob. Okay, I'm going to go post that in our Discord. So, for those that are watching, if you go to the website, actualofficehours.com, which is where people are submitting your questions, you can also join our Discord. And in our Discord, every time a question gets posted, I will post the answer to what we did on it here. So here you go. There it is for you, Bob. Enjoy. Again, the website's just right here. Join our Discord. Also, if you need help in math or are a little shaky on some of the foundational stuff, please check out our math boot camp. It's totally free. This is the same course I gave out to my students when I taught at UCLA for the first week in physics. And it's a cool little, I'd say it's like a remedial math course, but yeah, just click on that link. It'll show you how you can access it. It's totally free. And it just goes through all the basics, because we have a couple students every stream that come by and say, hey, I didn't really learn exponents, or maybe I'm going back to school and I don't really remember, what to do with fractions. No. That's a great course for you to sign up for. And it just has a bunch of practice problems, has a lot of lecture stuff that I wrote myself, also some of the fun videos that I made on YouTube. So go check it. It's there for you guys. Create a boot camp for advanced math people. Maybe if Naroski wants to create one, I'm down. I'm not an advanced math person. All right, let's see. I'm slowly becoming an advanced math person. Oh, here's another question. Okay, this is from 2. Yeah, if you have gaps, well, yeah, River, go through and make sure you know all the stuff. I know it might sound like really easy, but it's always a good refresher. I can't tell you how many teachers talk to me about how students are missing super basic things to be able to do in their class. Like, yeah, they don't know how to simplify exponents. Like, Mysterious says, I got questions. I'm 15 and exploring metamath and infinite metamath and going beyond logics. That sounds cool. Metamath. You're bad at multiplication? It's okay. Get good at multiplication. Alright, in recent years, astronomers have discovered sources of fast radio bursts in galaxies. Studies suggest that these sources may be a type of standard candle. Well, like, what do you mean, like a candle? Like a light up candle? Yeah. The closest has okay, a detector area of this much on the surface of the Earth received a burst of radio waves. In one burst, that many joules of energy was received in a time of 1.15 milliseconds. Show that the luminosity, yeah, luminosity is cool. I think luminosity is the total power radiated, right? So if you could think about something here, right, having a luminosity equal times 2 times 10 to the 35 watts. First of all, that's 2 times 10 to the 35 joules of energy being radiated every second. And that's spherically symmetric, okay? So what we say is that, like, moves out like this in a circle. Or really a sphere. Right? Okay. So that energy then has to be distributed as you get further and further away over the surface area of a massive sphere. Okay? So if we wanted to, like, kind of draw like a sphere, right? This is where all the energy goes, okay? So you can kind of talk about like an energy density, which I think is called intensity. I think intensity is equal to watts per meter squared. And so that's like the power at any specific point. Okay. Okay. So I believe when we talk about, and then here, we're like somewhere here on Earth. And we're located a very, very, very far distance away. Yeah, Lux looks like Flux too. Yeah, it is very much like Flux. Yeah, it has like kind of the same equation. So we're like out here. So we're only going to receive, for instance, this whole 10 to the 35 watts gets distributed over this entire surface area. And then where we are, radially outwards, we're only going to get a portion of that. So I think the first thing is to figure out the intensity here. Basically figure out, like, how much watts per square meter is available when we're this distance away. And so that's going to be equal to 2 times 10 to the 35 divided by 4 pi r squared. So 4 pi r squared, that's the surface area of this sphere if we were a distance r from the source, which in this case, the distance we are from the source is 4.6 times 10 to the 24th. Okay, so this is big, big number. So times 10 to the 35 over 4 pi, and then this is 4.6 times 10 to the 24th, and then that's squared. Oh. Yes. Well, here's what I'm going to, like, kind of work backwards. I'm going to show that this eventually gets me to this. It is a sphere, yeah. So, yeah, let's just say that, like, if the luminosity was this, what would the intensity be? And then from the intensity, let's show that based on our detector and that amount of time, that's how many joules we would have gotten. It's kind of a backwards proof, I guess, but it still works. So Legendary calculated that and said that's 8 times 10 to the 16. I believe in that. Watts per meter squared. Okay. Now, this is the amount of energy per meter squared that can be absorbed on Earth, which is this huge distance away from the source. All right, so this is... Someone says 10 to the minus 13. Okay, so maybe some math got wrong here. I agree with this actually too, because this should be 10 to the 48. Yeah, okay. So, uh-oh, Legendary. Something's wrong with your math. Let's go do it again. Per steradian? Dude, oh no, dude. Is that like a thousandth of a radian? All right, 2e to the 35 divided by 4 divided by pi divided by, I think you forgot to square it, maybe 4.6. Solid angle. Oh, what's that? I've seen these terms before. I always thought it's funny when they start going into like minutes and seconds and like arc seconds and stuff. Okay, 7.5 times 10 to the minus 16. That looks a little bit more reasonable, right? Okay. Okay. So... Oh, I see. We're assuming it's this, and then I'm working backwards. I see. Okay. So then... If I take that and I multiply this by the detector area, that'll be the amount of watts absorbed by the detector. On Earth. So that... we said had an area of 1 times 10 to the minus 4. Pretty small detector. Okay. So that's going to be equal to 7.5 times 10 to the minus 20 watts. Okay. Which is equal to joules per second. So then let's see if that makes sense. Because the amount of joules we said... Well, here, let's just see like the amount of energy in 1.15 milliseconds. So let's just see if this matches. So this would be 9.4 times 10 to the minus 23 joules in 1.15 times 10 to the minus 3 seconds. I think this is going to come out right. Okay, so 9.4 e negative 23 divided by 1.15 e to the negative 3. Yeah, and that gets us 8.17 times 10 to the minus 20. So, a little bit off. Looks pretty close. But again, when you're dealing with like stellar things, as long as the exponents match up, you're usually pretty good. This is called being like good enough to an order of magnitude. Okay, so they're about the same. So yes. Nice. Cool. You wonder why we're so far off? It's because they said it was about 2. I think what it'll actually show out to being is that this is actually going to be 2.2. Like if we were to work backwards. We're not that far off. Like 7.5 and 8.17. What? That's a difference of 10%. Which would make sense, right? If we're off by 10% here, then being off here to 2.2 from 2, that would also make sense, yeah. What's up, Think? Yeah, it makes sense. Thanks, Psycho. Cool. Good question by 2. Thank you, 2. The reason why I wanted to go in this order, because it's a little bit... It would make more sense getting the right answer, but I feel like explaining the concept, it's easier to go from here to here. Okay, I'll buy it. Okay, I'll buy it. I sold you on it? Nice. Yeah, I don't know. I think it's a little bit harder for someone to start here and then somehow get to this. Yeah. This is... Yeah. 20% of a bunch? Dojo, that's huge. Okay. %10 can be a real big boom. It can, yeah. I mean, it's their fault. They gave a single digit of precision. Yeah, they should have given us a little bit more. Like, what? Like, come on. Come on, guys. Astronomy does tend to be, like, kind of fast and loose with stuff. They're just like, eh. Team old guys. Alright, let's see what we got next on the queue. This is Norwegian. Fun. Let's translate. What's up, Alistair? I am familiar with the Taylor series. Oh, there's a new ChatGPT. ChatGPT 5.2. Yeah, honestly, like 5.1 was pretty trash. So I'm curious about this. Oh, find the interval of convergence. Love this. This is fun. What's our stream? Yes, we have it on Twitch as well. So again, if you go to this website, for those that are watching, actualofficehours.com, this is where people are submitting screenshots for the questions that I'm going through. So whatever you upload, you can then click on the live queue, and then this is the queue of the questions we're going through. You can click on anybody's username, and it'll show you what the question is that they submitted. And then also, while you're there, if you want to watch on any of our other platforms, Twitch is nice because it's nice and like horizontal, but YouTube and Twitch will be vertical. Just that's how the algorithms work. You can also join our Discord. That's where we post all the answers to everything we work through today. And then if you want to check out the streaming schedule, this will tell you all the different streams that are going on, because I'm not the only person that does this. There are a lot of other fun people that do this. So for instance, tomorrow, Zach's doing like... Zach E, the 2i Pie, is doing a really awesome... kind of like a math trivia game on Twitch, and it's for the tournament winners, the Tournament of Champions, which I am one of the champions. So I will be on that tomorrow with Zach, and then it looks like he's doing a coding challenge on Saturday, and then all next week we got some streams. It'll probably be the last streams of the week, or sorry, of the year, because not many people need help with homework over Christmas. Okay. Sick. Not math. I've got an integral calculus exam tomorrow. This is one of the topics. Good. Come learn with us. We're going to go do it. Let's do it. Thanks for the follow, by the way, Mysterious Juice Man. Yeah. Oh, you found us on Twitch. Nice. Okay. Find the interval of convergence for the power series. So this is like values of x, right? That make this converge. This is calculus. This is calculus 2. Or like AP Calculus PC. Okay, let me think. I think I want to do I think I want to do a ratio test for this. Right? I want to do ratio test. Yeah? Can we do ratio test? Yeah, ratio test. Dubs. I love the ratio test. It's my favorite test. Let me pull up the formal definition of the ratio test real quick. Okay, there we go. Or like this is all right. This is actually, I like this image. This is better. Yeah, there probably will be 2 criteria because we talk about the absolute value of it, I guess, right? This is kind of the issue. It's the absolute value of this. Okay. So let's do an plus 1 over an. So an plus 1, all you do is you replace all these n's here with n plus 1s. So that's going to be n plus 1 to the third, 2x minus 3 to the n plus 1. And then we're dividing by an. So that's going to be divided by just the regular thing, which is n to the third, 2x minus 3 to the n. Cool. I smell an E coming. Is it going to happen? And then we're going to take the limit as n approaches infinity. Okay. Cool thing here is that by the exponent rules, right, since these are the same base, I can cancel this out. And then that's going to be... Oh, I see. Do I need to expand this? Do you guys think I need to expand this? I don't know if I want to expand it. I think I do need to expand it, unfortunately. Fuck. What's the perfect cube? Don't expand it? Lower orders go to 0? Okay. I see. Okay, so this is n plus 1 to the third, 2x minus 3. And then over n to the third, right? Save more time? Okay. So, this is going to be something order n to the 3 plus like blah, 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 blah. But I don't care about any of the orders, right? Any other ones? And then this is 2x minus 3. It's 1, 3, 3, 1. No, it has. It has. Definitely has. And then this is n to the 3. So, as n approaches infinity, right? All of these other terms that are lower than n to the cubed, those are gonna go away.
You're not that guy, pal. Trust me. You're not that guy.
We're just gonna get rid of those. So those are all gonna go away. Goodbye. And then you're just gonna get left with this over this, which is just 1. Uh-huh. Okay, so then I'm left with just 2x minus 3. Yeah. N plus 1. Oh, that's another cute way to do this. Oh, actually, okay. This is actually another fun way to do this. I like Fembox's idea. Okay, these are both to the same exponent, so I can just rewrite this as n plus 1 over n to the third. And then this is 2x minus 3. I see. So then, Fembox spreading fake news. Yeah, so then this is 1 plus 1 over n, all to the third, 2x minus 3. And then the limit as n approaches infinity means that this is going to go away, yeah? Yeah, if this was this to the n, then this would be e, but it's to the third. Okay, so this goes away. And you're just left with 2x minus 3. But I want the absolute value of that to be equal. So in order for it to be convergent, it has to be less than 1. So absolute value of this has to be less than 1. What's up, Taco? How is it possible that people found about logarithms if only possible with logarithm? I don't know about the history of the logarithm. Okay. So for convergence, absolute value of 2x minus 3 has to be less than 1. So, is this how you do this? I always forget how you do like inequalities. I think you do 2x minus 3 has to be less than 1. Or is it negative 2x plus 3 has to be less than 1? Is that kind of what we say? Is that right? Yes. What's the guy's Twitch? It's on here. If you go to the website, actualofficehours.com, There's a link here for watch live on Twitch. It's right there. Okay. So then 2x has to be less than 4, so x has to be less than 2. And then from here, I get negative 2x has to be less than negative 2. So x has to be greater than 1. Okay. Less than 2, greater than 1. There you go. This is your convergence. So I think when they say radius of convergence, they say the radius of convergence is equal to a half. Right, and that's the other way to say it. Yep. That's the cute way to say it, Ryan. Yeah. So you say like x minus 1.5 has to be less than 0.5. Right. So it's centered at 1.5. Always kind of think of that as like on a number line, right? If this is like 1, this is 2. This here's like 1.5, and then it's called radius because it's kind of, I don't know, it's kind of like a circle. It looks kind of like that, right? Something like that. Nice. Okay, cool. So interval of convergence is this. Radius of convergence is 0.5, center 1.5. Nice. Awesome. Okay, fun. Good question there. Mysterious Juice Man. And we got a raid from Physics and Depression. What's up, dude? We're just doing some radius of convergence questions that was just asked for. Yeah, shout out to Physics and Depression. Another awesome guy. He does physics on Twitch. Go check him out. I think I saw last time you were working through some OpenStack stuff, right? I do a lot with OpenStacks. I actually like I convert a lot of OpenStack's material to other platforms to kind of create like interactive learning textbook things. Time him out at once. Yeah, I kind of miss that. I miss getting timed out. It was fun. Because yeah, dude, physics it is right, dude. Like I will raid people, and then sometimes they do say, "Hey, if you gotta run and raid, it's totally cool." But otherwise, I'm like, "Fuck," I feel obligated to like say things. But usually, I have to fucking go somewhere. So I appreciate when you mandatorily force me to like take a break or just not respond. Nice. All right, let's see. Whose is this? Lexical, thanks for the follow. This was Hijip. Hijip is your name? That's cool. All right. So we're gonna take that question. We're gonna mark it as done, and then we're gonna go work on the next one. So let's see. Mark as done, and then that's gonna go right here into our Discord of all the questions we worked on today. So if we look here, where is HJeeps? Where is your question? There it is. Oh, I think you're Norwegian. Oh, so HJeep. Oh, okay, so it's like a Norwegian name. Sick.
That's dope.
I always love when we have students that we help from like all over the world. It's really cool. Math is a universal language. Today was eddy currents.
Oh, yeah.
Nice. Eddy currents are fun. I believe eddy currents are what occur when you have like solid pieces of metal moving through magnetic fields. Why is everything gold with you? Why not, dude? Just embrace it, dude. It's okay. Yeah, eddy currents are cool. This is an E&M thing for sure. Yes, exactly. Good. Yeah. When they're exposed to changing magnetic fields. Yeah, super cool. Correct me if I'm wrong. Is this how an induction stove works? Does an induction stove work with eddy currents? So, yeah, basically, oh, interesting. Okay, yeah. Textbooks make them more confusing. In some sense, they are not turbulent and not small scale. I'm pretty sure eddy currents are for induction heating. I want to say that's what it is. Because if you have current and you have a resistance, then you have power from like resistive heat loss. So I think that's how induction current induction stoves work. It's probably with eddy currents. It's cool. Cap, you're not a real bot. That is one application. Yep. Cool. Boom, boom, boom. All right, let's see what we got. Next question is from W. Talks about transverse waves. Ooh, this is cool. Optics. Dude, I mess up optics all the time. It's one of my least favorite things to teach, besides thermo. I love E&M though, so I would have loved what physics and depression was doing. Eddy currents are fun. I like E&M. E&M's great. All right, transverse wave passes through a polarizer. A and B are 2 points on the wave, a distance 3/2 lambda apart. The displacement of the wave at the point at A passes is at its maximum. Sketch a possible graph to show the displacement of the wave against the phase angle as it passes through the polarizer. Wait, what? What the hell is this question asking? Okay. Transverse wave. Okay, let me explain what a transverse wave is real quick. So, a transverse wave is a wave where the amplitude is perpendicular to the propagation. So, for instance, if a wave is moving in this direction, that's the propagation direction, you'll notice that it oscillates with an amplitude that's perpendicular to that. What a polarizer does is it kind of messes with what angle is allowed to like pass through it. E&M is great until you're designing a PCB, then it sucks. That's not E&M, that's like double E. Okay, here we go. Polarizer. Let me show what a polarizer is. Let me see. Let's say like two polarizers. Two polarizers. Good. Okay, I love hyperphysics. Based hyperphysics, honestly. Okay, so for instance, these are some polarizers. So what happens is if you have light that's just naturally coming from the sun is oscillating in all sorts of directions perpendicular to its propagation direction. So like you have waves going this way, you have waves going this way, you have waves going this way. And that's why it's, I guess we call it like circularly polarized maybe. Or unpolarized. Now, when it goes through something like this, let's say for instance, which has a bunch of slits in this direction, now the only waves that are allowed through are the ones that match that direction of the grating. So if you had a bunch of like vertical slits like this, yeah, dude, polarized sunglasses are great actually. Yeah. Let me show the diagram from that actually. That's also really cool. One second. Sunglasses, polarized, physics. Physics. Yeah, because circularly polarized is a type of polarization. You're right. I want a fun... Yeah, okay, so this is another great little graph. Got a lot of cool graphs here we can use. Yes. But guys, isn't the Earth flat? There's always somebody. There's always somebody, dude. Okay, so here's another way to understand polarization. So, for instance, if you had waves that were vertically polarized in this direction, and your slit is vertical, then the vertical waves are allowed to go through. If you have horizontally polarized waves, and you try to go through a vertical slit, that actually kills them all off. And that's why you kill the amplitude. So, unpolarized light from the sun bounces off of the ground. And it so happens that when light bounces off of surfaces such as the Earth, it becomes more polarized in the horizontal direction, okay? So, if your sunglasses only allow vertically polarized light, then the light that bounces off of the surfaces, which is horizontally polarized, will get canceled out. Yeah, sorry, sunglasses. Well, some glasses are polarized too, honestly. But yeah, sunglasses mainly, yeah. And you can actually tell this. I don't have any sunglasses here in my studio. But if you take like your cell phone screen and you look at sunglasses that are polarized and you rotate them, you'll find that there's a certain angle where you can't see anything on your phone screen. And that's because you're matching 90 degrees to the polarization of the light coming off of your screen. It's actually really cool. So yeah, that's how it works. Yes, and there is an angle that does it. Okay, so let's go to this question.
So it says there are 3 halves. Thank you, Taco Cat. Got the baby voice going. So if we have a wave, let's come up with a wave here. And they said that A passes at its maximum. Okay, so let's say, for instance, this right here is its maximum, and this is A. And then the wave, let's draw like a wavelength would be. So a wavelength would be from here to
here, but then I need 3 halves of a wavelength. Okay, so here to here is half a wavelength. This is 2 halves of a wavelength. This is 3 halves of a wavelength. Okay, so this right here is B. Okay. Sketch possible graphs to show the displacement of the wave against phase angle theta as it passes through the polarizer. So I guess what would happen is the displacement would be the same, right? Because they're both maximums in their own. I mean, this is a minimum and a maximum, but they're both maximum amplitude. So the only difference is that they would be 180 degrees from each other. Yeah. Oh, that's actually kind of cool. So yeah, let's say for instance you had. Let me get a picture. Because I can't draw this stuff. Two polarizers. Yeah, here we go. This would be a great picture. Okay. So, Yep. So let's say, for instance, this is at like point A. Or actually, well, let's see what they kind of want this. Yeah, if this is A. And then this right here would be B. And let's say this is, again, the angle between what the polarized light was and the polarizer. What's up, Westu? This would end up being at the same angle, but on the opposite side. So you could say that, like, for instance, this is theta. That's where they would both be. Okay, cool. I think it's a good explanation of that. It's going well, Westu. How's your Thursday going? All right, nice. Good question by Dubs. What happened to everybody? Everyone's still here. What type of homework did you do? I do anything math and physics, or sorry, math and science. Anything middle school up through college. Florian says, "Yep, even I understood." Nice.
That's dope.
Love that. Love that for you. Let me get my... Boom. Oh, what's up, Daniel? Do you know the radius of D's nuts?
You done messed up, Aaron!
Damn it, Casey. Sorry, my TikTok chat just like bonks out every once in a while. You can definitely still submit something. Yeah, we have an hour and a half. I might go even longer. Might put another half hour on it. What am I looking for? I need to submit this question. There, this was W's. All right, let's see. What's next? Ooh. This looks like more translating we gotta do. Translate. Anyone have tips for physics? Physics, the best way to study for physics is to try to do a bunch of different problems and solve them different ways. Because, learning, for instance, oh, I could solve this with conservation of energy, oh, I could solve this with mechanics, will help you out when you're given a question on a test and maybe one way is faster than the other. I would say that's a very, like, valuable thing. How do we whisper? I don't know how you whisper. Are you talking about like on Twitch? All right. Let's see. Find the value for A such that the following limit exists. Ooh. All right. Well, let's plug in A. Well, first of all, this does look like a fun one. I think this is going to be the hospital rule. We're going to do the hospital rule, guys. I think it's going to be the hospital rule. La hospital.
Oh, yeah.
Yeah. Okay, so because if I plug in... Watch what we get. I get e to the 0 minus 1 minus sine of 0 over e to the 0 minus 1 sine of 0. This is 1 minus 1, which is 0 minus 0 is 0. This is 1 minus 1, which is 0 times 0, which is 0. You get 0 of 0. Which is a bad thing. I call it the hospital rule. Yeah. It's just to piss off my French friends. L'hôpital. Was he French, actually, by the way? Sounds French. Juice Man, chill, by the way. Are you okay, Juice Man? Okay, when this happens, this is called indeterminate, which means we can the calculus and physics tutors. Oh, that's cool. We can use L'Hopital. L'Hopital's rule says that if I get 0 over 0, I can take the derivative of the top and the derivative of the bottom and take that limit. And whatever that goes to, the other limit went to as well. Ah, it was French. Guillaume de L'Hopital. Okay, so let's do it. So let's do d dx of the top. Yeah, I would split this into two as well. Oh, wait. I actually, whoa, I see what physics and depression is saying. You're saying you would split the top into two different ones? Actually, I really like that. That's a really smart idea. Yeah, let's do that. So physics had a great idea. So, because we have, like, for instance, this is e to the x over 2 minus 1 minus sine of ax. That's actually really smart, because, yeah, that's going to cancel. Yeah, otherwise this becomes a nasty integral. E to the x over 2 minus 1 sine ax. Anytime you have, like, a minus b over c, you can write that as a over c minus b over c. Great. Okay. So, I can do it as this minus this. Okay. So if I do that, I get e to the x over 2 minus 1 over e to the x over 2 minus 1 sine of ax minus sine ax over e to the x over 2 minus 1 sine ax. Now, here's the question, though. Am I allowed to just cancel this? Because technically it's 0 over 0. Or maybe I can. Yeah, the issue is that gets you 1 over 0, right? So if I cancel this, I don't think I can use L'Hopital's rule. The only issue, right? Because then this is 1 over sine ax. And then this would cancel and this become 1 over e to the x over 2 minus 1. And the limit as x approaches 0 of that. Yes, exactly. So then you have 1 over 0 minus 1 over 0. So infinity minus infinity is not helpful, unfortunately, yeah. This is cool. I mean, this is good intuition to do this. I think the issue is that I can't do L'Hopital's rule when I have this. Yeah. Okay, so let's keep it then. Let's keep it. Let's keep it the way we had it. That's a good try. I didn't see that. No, that's a cool little. How'd you get so good at math? I don't think I'm that good at math. I've done a lot of questions. I will say the one thing I will attribute to my ability to do math is having done math. There's no shortcut to really being able to do math other than to do more math. Man, there's a really good study that just came out, and I feel kind of bad for it. Or for the next generation. What is it? Let me find it. It was a scientific study, short form content, brain rot. Yeah, this just came out the other day. Researchers warn of emerging risks tied to short form video.
Bruh.
Uh-oh. So, a review of 71 studies. Here we go. It's a PubMed thing. So this is real. This is, NIH type shit. I think, yeah, if you want to like read this, but they basically said that short form video creates brain rot and leads to like ADHD. I mean, this is all shit we already knew before. Like I already knew that, constantly swiping on things is not great for you. But yeah. Anyways, I forget where I was going with that. I think one of the key things of that study was showing that people who are comfortable with sitting and staring at something and not immediately like giving up do a lot better. And I think a lot of what like short form swiping, whatever content has taught us is that if I don't like something and I don't think I can get it, I can just swipe and just go to the next thing. But in math, for questions like these, where things are difficult, you have to kind of build up a muscle of being cool with being like confused and bored and not knowing what to do, but at least sticking with it and sitting and staring at it for enough time for your brain to eventually make the connections to solve it. So yeah, exactly. But it's cool that there's actually yes. Oh, you got a chemistry question. Okay, cool. We'll do some chem. All right. So again, back to this. Taking the derivative of the top and the bottom, this becomes 1/2, because this is a chain. This is a chain rule of e to the x. So e to the x over 2. So 1/2 e to the x over 2 minus derivative of sine is cosine, but then also chain rule because there's an a on it, so it's minus a cosine ax. All right. Doing this derivative, this one kind of sucks because it's a product rule, okay? Because I have like something times something else, and so the derivative of that is a prime b plus b prime a. Okay, derivative of this we just found out, right? 1/2 e to the x over 2 times b, so that's sine ax. What's up? What's up, Arethes? Appreciate the follow. Are we almost to 2200? That's pretty cool.
That's dope.
Appreciate all the follows we've been getting lately. Okay, plus the derivative of this, which is a cosine ax, and then times e to the x over 2 minus 1. Okay. So yeah, so let's look at this, right? So the limit as x approaches 0 of this, well, this is going to be 1 minus 1, so this is 0. This goes away. I don't believe you after the yeah, Femvox, dude. Our trust has been eroded. Okay, this is 0. Wait, this is still kind of fucked. Right? Wait. Ah. I don't want 0 on the bottom. I really don't. Right, let me see. Did we do this right? 1/2 e to the x over 2 minus a cosine x. Yeah, exactly. We also need... Exactly. I also need 0 on the top to have hope. Otherwise, yeah, we have no hope here.
Surprise, motherfucker.
Okay. I'm just making sure I did these derivatives correctly. I'm pretty sure I did, though. Right. 1/2 e to the x minus 2 sine ax plus a cosine ax. Okay. Ooh, okay. Right, okay. Right, so as x goes to 0, this goes to 0, this goes to 0, so I need this to also equal 0. For hope. We need hope. We want hope. So the only way for that to happen is for 1/2, because this is e to the 0, which is 1, minus a cosine of 0 is also going to be 1, to equal 0. So a must equal 1/2. I agree. Okay. Can I just leave with that? Can I just leave it? Just be like, well, it has to be. I guess, unless we should probably take another derivative, right? Okay, so fine. Okay, so let's do another round of the hospital.
You done messed up, Aaron.
Another round at the hospital. Do another derivative. That's going to give me 1/4 e to the x over 2. And then that's going to be plus a squared sine ax. Derivative of cosine is negative cosine. Okay. Oh, this is a pain. Okay, 1/2. So this is, okay, 1/4 e to the x over 2 sine ax plus 1/2 e to the x over 2 a cosine ax plus 1/2 e to the x over 2 a cosine ax plus or minus a squared sine ax e to the x over 2 minus 1. And please, for the love of Christ, make this thing not 0. Okay, well, so limit as x approaches 0. This goes away. Ooh, this survives. Love that. Right? This will be okay. This will also be okay. And this will die. Okay. And then this will die. Oh, okay, cool. Wait. This is really cool, actually. So this should just get me 1/4. Right? And then that's a half of this plus a half of this. So over... and that's 1. And that's also 1. Oh, so it's 2a, right? No, it's just over a. But a was equal to 1/2. So 1/2 by a fourth is equal to 1/2. Right? I do that right? Because when we plug in 0, right, that goes away. This becomes 1. This becomes 1. This becomes 1. And I have 1 over 2a. 1/2a plus 1/2a, which is just a. Cool. Nice. Okay, great. Love and yeah, nice. We got it. Good job. Appreciate it, guys. Said looks good. I'll take it. Nice. Bean says, you're good at math. I love your videos. You taught me how to do related rates in grade 12. Sick. Yeah, my related rates video is pretty popular. I need to do more of those videos. It's been a while since I made them. Appreciate it, Beanzo. This is Hajilp. Hajilp. Is there any place I can hire a mathematician or someone with experience in probability math? What level do you need? I don't personally private tutor people anymore just because I'm so busy. But I have other friends that do. If you wanted to hire one of them. Ramton's a great guy. Or anyone else, speak up in my chat if you want a client. Oh, calculate casino rewards and house edge system. Is this the plot of a I don't know, the next like Ocean's 11? I'll tell you right now that the casinos have a much bigger payroll on like paying people to figure out how to not how to lose money. Okay, someone gave me a math Olympiad question. I don't know if I can do a math Olympiad question right now. This one looks hard. Oh man. Mass M moves down by 1 meter. Wait. Rolls without slipping. Yeah, most casino games are mapped out. Yeah, I agree. If there's money, there's a it's a conservation of string problem. Okay. You don't think this is too hard? Or we can try it. Femvox says the answer is D. Oh wait, no, not that one. All right, let's see. DJ, I can't break down ionic questions. Just a minute. We'll do it. All right, consider a cylinder of mass M and R rolling without slipping on slope H as shown. A string is wrapped around cylinder C. When M moves down vertically by 1 meter. Okay. So this is going to move down by 1 meter. So this string has to move up by a meter, right? So wait, this has to translate a meter, right? A meter of string at least. I see. And then if you have a meter of string and it doesn't slip, right? That's the key thing. It doesn't slip. If it slipped, it would just pull the whole thing up a meter. Right, I don't think it depends on the masses. Physics, yeah. Lock it in. Yeah, what's up, Zach? Shout out, Zach. I'm excited for the tournament tomorrow, dude. I'm getting ready. Femvox, I'm coming for you, dude. I'm coming for you, dude. Yes. So if it slipped, this would just move up a meter. However, it doesn't slip, so it rotates. And I think we can figure out how much. Oh, wait a minute. Shouldn't that also equate to a linear translation, though, right? I'm pretty sure it's 0.5. Physics thinks it's C. oh, here's also the question in physics though. They said how much will it move vertically, right? So that's like this movement and then in this angle. So that's going to be whatever that is, like sine of 30, which is 1/2. Okay, so 1/2 times 1 should be 0.5. I feel like sin is important. Sin is important. But here's my question, guys. Sorry. We all sin a little from time to time. If this moves down a meter, right, this rope should shorten by a meter as well, correct? So, if it shortens by a meter, why does this only move up half a meter then? What are we doing? This is like a physics Olympiad question. If the cylinder, oh, the string is unspooling. Oh, if the cylinder rolls half a meter, a whole meter of string can unravel from it. Oh. Oh, can it? I think the string like represents the amount of like, you know, arc length that's being covered. Right? And if you're covering a meter of arc length, doesn't the thing move up a meter? Yeah. I think the answer is C. Someone said the answer is 2? How's the answer 2? What? Why is the answer 2? I'm tempted to say it's C. Let's see what the new and improved ChatGPT 5.2 says. It's supposed to be like really good now. Vertical displacement. I agree, so it's half of that. Yes, the 1 meter must come from the rotation of the cylinder. I agree. Dude, I love chat. I know, Zach doesn't like chat. Chat says it's 0.5. I'm tempted to say it's 0.5. Who has the answer for this, by the way? Who submitted this to me? I'm sticking with D. Femvox, one sec. Let me copy this image in. Ask ChatGPT the number of S's in assessments. Don't do it. Gemini says D. Ooh, the battle's on, dude. The battle's on. Let me think about this. Sorry. The total length of string is the sum of the length to the first pulley and the length around the pulleys and the vertical length of mass M. When the system moves, the change of the string length is due to the cylinder moving up the slope and the unwrapping of the string. Since the cylinder rolls without slipping, the distance the center of mass moves along is related to its rotation by r theta. You're good, Gemini? Yeah, okay. Delta YM must equal the change in the string length. The change in the string length is due to the cylinder moving up the slope. Oh. Okay. Yes, okay. I see what you're saying. Okay, I get it now. I get it. Yes. Okay. So, yeah, okay. Not only do you have this amount that is being shorter, but now you have this amount that is being shorter, right? Is that what we're saying? Okay, I get it. So that's why it's doubled. Okay. Then I retract, and I do think the answer is D. I see. Okay, cool. Thank you. You guys showed me the light. Bad ChatGPT. 5.2 still getting things wrong. Gemini still remains supreme. Yeah. Okay, cool. The battle of the GPTs, dude. Let me save this. What's up, Holy Shia? I need to keep a score against GPT. I don't know, that's why this fucked up. 1 second. There we go. Okay. What's up, Doc? What's up, Anuvan? Let me annotate this a little better. Amir! Are you good at math? I like math. So, yeah, I think I'm pretty decent at doing it. I would say so. Just getting off my differential calculus coursework. Nice. Enjoy the holidays. That's what I say. We're getting close to the holidays. All right, let's see what Millie's got. All right, Millie. I think Millie's asking whether this converges or not. Or, like, for what values of n does this converge? How are you with D math? What is D math? Like differential math? What is D math? Oh. This dude, isn't this just the P series test? So it converges for 3 minus P is greater than 1. Yup. P is less than 2. Nice. Cool. Easy. Love that. That was great. Nice job, Millie. Mysterious Juice Man. What is this? Is this a question? The omni-branch theory? A structural theory of infinite mathematical branching? By the way, I'm 15, so please don't explain it like real mathematicians will understand it. Thank you, Cypress! Yeah, that was an easy summation. We like that one. What if the architecture of all possible maths had a generator or a universal rule? Oh yeah, this is a real quick one. I don't know. Juice Man. Because I don't know what a... Sorry, first of all, I don't know what a generator or universal rule is. Paid shit.
Oh shit, not good.
And then they did that right as like finals were ending, and so it was a real crunch. It was like, well, nobody can get their grades now. Thank you, Ely. Love all the jewels. I don't know what all those combo things are, but cool. Do I still teach at UCLA? I don't. I taught last quarter. I'm not teaching this quarter. I probably won't teach next quarter. But it was fun. I had a good time there. Below is a graph of the ball's motion. Provide an interpretation of the ball's motion. Ooh, okay. So here the position is the same. So you could be like rest. Then falls down at a constant speed. Why can't you share your question? You can share your question. Use the website there, actualofficehours.com. Just submit it to the cube. So yeah, because the slope of position is speed. So this is falling down at a constant speed because the slope is constant. And then rests. Yes, there you go. Anuva knows how it works. Okay, a man starts at the starting line, walks back slowly and steadily for 6 seconds. Then he stands for 6 seconds, and then he walks steadily twice as fast for 6 seconds. Sketch the D versus T and V versus T showing his motion. Okay, not hard. This is distance. This is time. So he does this for 6 seconds, and then he does something else, right, for 12. This would be his motion, right? So walking back at a constant speed would be this. And then he walks back towards it at twice the speed. Twice the speed means now the slope needs to be twice as much. So for instance, if this went to like -3, this would need to go all the way up to +6. And if you were to show this in terms of velocity, so velocity graphs are always just the slope of the position graphs. The slope here is just negative, and it's not too crazy. But then the slope here is positive, and it's much more positive. So you'd have something like this. Thank you. Fem is right. He also stood for 6 seconds. I should fix that. Yes. Yep. Thank you. Thank you. Thank you, Fem. I was getting ahead of myself. Let's do it this way. There we go. That's what's supposed to happen. And then this is 18. Yeah, there we go. And let's connect these. So here's a cool thing. So between 6 and 12, his slope is 0 because he's not going anywhere. So his speed is 0. So that's going to be just like that. And then from 12 to 18, he then has twice as fast of speed. So the value of the velocity is going to be twice as good. Yeah, this is one of these silly questions where technically the derivative, the velocity is discontinuous. But whatever. Yeah, the vertical is hard to see on a phone screen. Yeah, the reason we do it, Anuvan, vertically on YouTube and like TikTok is because that's how the algorithm puts us to see people. Law says they're trying to put in a replacement classes during the Christmas period, but I'm already going. Yeah, what? Dude, what? No. They want you to stay there during Christmas? Get out of here, dude. Okay. Ooh, this is cool. This is V versus T. Sketch the D versus T graph. Well, I can't really read this. It's really hard.
You're not that guy, pal. Trust me. You're not that guy.
What are these numbers? Here, I'll do this one for you though. At least I can't read question 8. I need numbers for it. Okay. A car is moving forward when the brakes are applied. Ooh, that's kind of cool. So it's probably like has a position that looks something like this. Let's say constant speed. And then the brakes are applied. That ends up, well, actually, here, we should do it like this. It's going to end up looking like this. And then the tangent lines, those are the velocity graphs. This is velocity. We need math in widescreen. Bigger the better, yeah. Math HD, bro. Yeah, there we go. So eventually the velocity is equal to 0, which is when it stopped. And then this is like fast, slower. Cool. All right, nice, Kyle. Hope that helps. There should be a reaction. Yeah, it should be straight and then a parabola. Okay, do you want me to do that? You want me to do that? I can do it. I can do it. We can fix it. We can fix it. It's the beauty of a whiteboard. There we go. So here we can say here like brakes applied. Kyle. Ali says this is really hard. I wonder how they test those killing children distances. Here, have you seen the ones where they throw like the mannequin out and like see what happens to it? They're trying to see if the Tesla will stop. Let me do. I want to do a chemistry question. Anyone have a chemistry question here? No, math. Haven't done. Ignore this and ignore the other one. This is the correct one. This is good. This is physics. We will do physics eventually. Where is? It's more math. Math. Lagrange multipliers. Oh, okay. This is easy. Here, let's just do this real quick for a lucky cat. This is chem. I can bang this out real quick. You have a chemistry test tomorrow. Uh-oh. Yeah, this is kind of chem, right? Yeah, okay. The Rutherford model of the atom and the Bohr Rutherford. Isn't one of these like the plum pudding? The plum like who the fuck knows what plum pudding is? But yeah, the plum pudding model. The last one's chem as well. All right, I'll do a couple chem questions just because. There we go. I thought it was the Rutherford method and the Bohr model. Because Rutherford did an experiment, right? Yeah, this is Rutherford's experiment where he shot like gold foil with a bunch of alpha particles and noticed that like it's scattered at like random angles, which means that the electrons or whatever, the atoms it's in must be like moving around a bunch in order to get different like deflection angles. Like it's not static. Okay, say Rutherford. I don't think there's a Bohr Rutherford model. Yeah, here we go. These are all the models. These are fun. Okay. Yeah, this is Dalton. Dalton felt like atoms were just solid things. And then J.J. Thomson came around and he's like, I think it's a plum pudding, which means it's kind of this like homogeneous mixture of protons and negative things. Okay, cool. So then Rutherford, I guess, came with the idea that the electrons must be orbiting the positive thing and that there must be like space. And then Bohr came up with that they must be quantized into like different radii. Right? Yeah, okay. What's up, AFG? What do you want to say? Let me talk. Well, what do you want to say? What's up?
What? I just want to wait. Do you know the Bohr model? It's basically just saying that it's like electrons travel in like circular orbits, and then there are like fixed distance. It's also called like being quantized.
Quantized, right? Yeah, I agree with that.
Yeah, they're quantized, and then so the potential energy of the electron is related to its distance from the nucleus, right? So when an electron absorbs a photon of energy, it excites it, and when it falls from a high energy level to a lower one, it emits a photon of light. So basically,
Yes.
he had like rings around it with like the farther the ring is from the nucleus. Yeah, basically.
Okay.
Yeah.
So Rutherford just said, I guess, that the electrons orbit, but not
Yeah.
necessarily in like quantized rings.
Basically, yeah.
Okay, that's cool.
Rutherford, it's like he didn't have a model of the atom. He just, I mean, he kind of did because he did the gold foil the experiment, right? So based on that, because if you look at it closely, it's once the alpha particles hit the gold foil, some of them deflect, some of them pass through, and some of them are deflected at like some
Weird ass angles and stuff. Yeah.
Yeah. So it's because the mass of the atom is concentrated at the nucleus, right? So that's what he was trying to say. He was trying to say because here, look, let me give you a good picture of it. Look, so like the atoms in a gold foil, right? This is what he was trying to say, that some of them pass through, but he mostly was trying to say that there's empty space. Like atom is mostly empty space. So like only the red dots is what matters. Everything else. So you see like whenever it deflects,
So those are the nucleus. The nucleus, right? Nuclei are the red things.
Yeah, nucleus. So
Okay,
whenever
cool.
it hits the red dot, I mean, what am I saying the red dot for? But whenever it hits the nucleus,
Whenever it hits
deflect.
this, yeah, it deflects.
Yeah.
Yeah, okay.
Whenever it slightly hits it, it deflects at like a weird angle. Yeah. So
Nice.
he didn't have like a model for the atom, but Bohr kind of had a well-defined one.
Sick.
My man.
Okay, Lucky Cat. Does that make sense? I feel like that's pretty chill. It's a pretty chill explanation. Thanks for the explanation there, by the way. That was good. I forget all the different ones. There's so many different ones. All right, let's mark Lucky Cats is done. 6. Okay. Legendary says who's talking? That's AFG. AFG's a pretty smart person in our Discord. Let me see. What else we got? Ollie, you've been asking me for a while. Maybe I'll do yours. Is this a nightmare though, dude, bro? Are you gonna hurt me with this? People hurt me with questions sometimes. Cosecant squared over 1 minus 3 cotangent of 2x. Well, I know that. Wait. I think this is U sub, no? Right? Because, what is it? D dx of cotangent of x is equal to negative cosecant squared. It's not a clickbait question. Where's clickbait, dude? Where is he? Is that derivative? Yeah, derivative of cotangent is negative cosecant squared. Aha. I think I see how we're gonna do this. But ooh, that's 1 over the square root of u, and then this is kind of annoying. Okay, I think I see what we do. So let u equal cotangent of 3x. So then du or cotangent 2x. Sorry. And actually, I think I want it to be the full thing. Yeah, let's make it the 3, because I think I want this just like 1 minus the square root of u. Let's like kill 2 birds with 1 stone. So du is equal to negative 6 cosecant squared of x dx. Right? Because this is going to pop out. Oh, that's cosecant squared of 2x, right? Yeah. Okay. So, now my integral is 2/3 or negative 2/3, right? Negative 2/3 du, right? Because this thing shows up here. Like that. It's just negative 2/3 of it.
Sorry to interrupt, but wouldn't it be easier if you took u to be just cot x?
Well, because I want this. I want du over 1 minus the square root of u. That's just that's neat.
Think about it. What I would do is like you can express cot 2x in terms of cot x.
Oh, I see what you're saying.
Yeah, what is that?
Yeah, I see.
Cot square x minus 1 over. Is it cot square x minus 1 over 2 cot x or something?
Well, no, if you write this whole thing as this, then du is just equal to negative 6 cosecant square 2x. Well, because watch what happens here.
Okay, let me see.
Because now I have the integral of negative 2/3, right? And then this is 1 over the square root of u. Done.
Yeah, that works, I guess.
Yeah, this is much easier to deal with.
Yeah, my method was just kind of long, I guess.
Yeah, I was looking at this. I was like, oh, 1 minus the square root. Yeah.
What I was thinking is like if you do u equals cot x, then you can.
Polymath says not negative. Oh, yeah. So there's a double negative here. Sorry, this is positive. Yep, good. Good catch. I forgot there's a minus here, and then you also get the minus from cosecant squared. Okay, cool. So this is negative 2/3 u to the 3/2 times 2/3. Oh, wait, there's not a minus here, right? No minus. No more minus. Okay, cool. Okay, so then it's just 4/9, and then that's going to be the square root of 1 minus 3 cotangent 2x cubed. Yeah. That's just ugly. Okay, but I think that's how you do that. Yeah, nice. Okay, cool. Nice question, Ollie. Plus C.
You're not that guy. You're not that guy.
Oh, no, dude. I messed up. I missed the plus C. It's okay. I'll go fix it. Thank you, Polymath. I'm just like, whatever. No, you're right. Yes, you can DM me. Okay. Let's see. I'll do this one. Stefan. A lot of questions. Dude, yeah, seriously. Constant integration, dude. Get out of here, dude. I taught calc for 37 years. Bless your soul, dude. I can't imagine the amount of times you had to tell people to add plus C. I bet if you had a penny for every time you had to say you forgot the plus C, you would be retiring at a penthouse in, I don't know, Bali or something right now. Okay. A pool's ball was shown, photographed 8 times at equal time intervals. Is the pool ball motions uniform? Sure. Looks like it's covering the same distance every time. So like, yes. Delta X over delta T is constant. If you wanted to graph that, D versus T would just look like this. V versus T would just look like this. If it was accelerating, so if it's accelerating, that's kind of cool. That means the distance between it would have to be increasing, right? So this would be like positive acceleration. So this would be positive A. Because notice that delta X over the same like snapshot in time would need to be getting like bigger and bigger. And then if it was negative acceleration, it'd be the opposite thing. So that goes from like big distances to kind of smaller distances. Yeah, negative A. Acceleration is often a difficult term to understand. How could you best explain the acceleration of a car to a non-physicist? Ooh.
Just acceleration.
Just acceleration.
How can that be hard to understand?
Well, so there's some weird things about like speeding up and slowing down. I understand why this is sometimes confusing. Because acceleration is a vector. So let's say, for instance, you have something going at a velocity equal to 10 meters per second, and then now the velocity is going to 3 meters per second. What would the acceleration be here, positive or negative? Let's say this is like T0, this is T1. This would be negative, right? Because the velocity is going down, right? V goes from 10 to 3. But now let's make this a little harder. Let's say it's going here at a velocity of, let's say, negative 8 meters per second. Like, let's say it's going to the left, and then at a later time, it's now going at v is equal to negative 2 meters per second, right? You might be tempted to say the acceleration is negative, right? It's decelerating or something. But in fact, A here is positive because velocity is going from negative 8 to negative 2. So that's an increase in the velocity. What's weird here, right? This is slowing down in terms of speed. And then this is speeding up. In terms of speed. Or like the other example they would show is, right, this is negative acceleration. You'd have to be doing like, yeah, -8 to like -10 meters per second. This is also negative acceleration because velocity is going from -8 to -10. And this is speeding up. So, or no, this is slowing down, sorry. Yeah. Oh, no, so this acceleration is positive. No, this is negative. Dude, it's the left, right down. That stuff messes with me, dude, because I'm like, wait a minute. It's going this way, but then it's going more this way over here. It's because this is the times. Yeah, okay. I think where students get like kind of hung up is they think about this. If this is t0 and this is -8, and then this is -10 meters per second at like time 1, technically this is negative acceleration, but it's speeding up. Whereas if something is going this way at 10 meters per second at t0, and then it's going at 5 meters per second at t1, this is also negative acceleration, but it's slowing down. That's what I wanted to say. Sorry, that's how I wanted to say it. Just flip your axis, yeah. Yeah. Well, I mean, people think of it like physically, right? Right? It's doing this, and then it's doing this. Whereas this is doing this, and then doing this. I think the relation between it is speeding up is when velocity and acceleration are in the same direction. That's the thing you learn. So speeding up is when velocity and acceleration same direction. And then slowing down is when velocity and acceleration are in different directions. Because this is a question that always comes up on exams. You're like, oh, if my velocity is positive, but my acceleration is negative, like what's happening? Right? This is an example of velocity is positive, right? You're going to the right, acceleration is negative. That's slowing down. But then they'll be like, oh, what if your velocity is negative and your acceleration is also negative? Such in this case, right? Or this case, right? This way to this way. That's speeding up. Yeah. It's kind of a tricky one. It messes with people. So that's why acceleration can be like tricky. So explain the acceleration of a car. Let me think. I think it's like the change in the speed and like whether it's also in the same direction. But okay, you can also just say like change in velocity over change in time. But tell them that like direction matters. Okay. Uniform motion is constant slope. What are units for the following things? I'm not doing 6 examples, but meters, seconds, meters per second, meters per second squared. Nice. Cool. Good question, Stefan. Let me know if any of that didn't make sense. I'll go through it. Got 24 minutes. 24 minutes to save the world. Where is Stefan's question? So here, we'll delete that one. There was some good solid math on that. There was, yeah. Right, so wait, who submitted this? Funness for brain teasers? This is kind of fun. Who's submitting this to me? Oh, coming up? Okay. Okay. None of this acceleration and velocity bullshit. Average rate of change. So that's delta y over 2 between these two, which is, what is that? That's 1/2. Describe how the function is transformed. Yeah. No, this is not left 2. This is to the right 2. And this is up 5. Wait, how did they get both things backwards? Oh, wait, sorry. It's... Oh, I fucked this up, Jeff. Wow. No. The clock is invisible? I think we got another sub then. That's what happened. It's because the clock is up by the... I need to change the sub goal. Okay. Sorry, I messed this up. Average rate of change between 2 and 4. That's 32 minus 8 over 4 minus... I was stuck in physics land. Yes, 24 over 2 is equal to 12. Thank you.
My man.
What is the reflection of f of x squared? I guess it's reflected across the y-axis. Did they call it like a horizontal reflection? You did 1 and 3 yourself? Yeah, dude, yeah, what? Yeah, same. Solve the equation by square roots. Oh, this is fun. Divide by 4. Divide by 4. X plus 4 squared equals 9. Square root. X plus 4 equals plus or minus. Don't forget. So that's equal to negative 4 plus or minus 9. So that's equal to 5 and negative 13. This is functions. What's up, Riley? 3, not 9? What do you mean 3, not 9? What? I think they want negative x squared. Oh, they just want to say what the reflection of this is? Square root of 9 is 3. Yes. Duh. Jesus. Okay. Sorry, we're entering the end of the stream, and I'm starting to get tired. I will start making mistakes. Negative 1 and negative 7. Cool. There we go. Punch drunk. Yeah, I'm tired. So this could also be y is equal to negative x squared, or y is equal to like negative x squared. Which, yeah, funny enough, right? That wouldn't do anything. Yeah. This would be reflect whatever over x-axis. They don't. I am triggered, dude.
Disqualified.
Okay. Diego solved the equation below. How did Diego fuck up? Diego fucked up the same way I fucked up.
You done messed up, Aaron.
He forgot the square root. Oh dear.
Disqualified.
I did the same thing. Come on, Diego, dude. Don't be like me. This should have been 6. No, Diego. No. Okay, come on, Diego. Okay, nice. Great. All right. That was funness for brain teasers. Thank you. All right, burning through as quickly as I can. Khaled. Ooh, this is fun. Okay. Diego has a PhD but struggles with basic algebra. Same. Okay, x is between negative half pi over 2 and 0. Solve this. Fascinating. Well, this is sine times sine cosine plus cosine times sine cosine. So we can factor that, right? So that's sine plus cosine. I had my final yesterday and I finally passed. Yeah, congrats, 7, dude.
That's dope.
Congrats on passing Calc 2, dude. That's dope. Nice. Okay, cool. So then I need to know when this is equal to 0 or when this is equal to 0. And between 0 and pi over 2, that is nowhere.
You're not that guy, pal. Trust me. You're not that guy.
So this is nowhere. Sine plus cosine has an identity, and I think it's at negative pi over 4. I think it is too. Yeah, so sine equals negative cosine. I guess you could divide it, right? And you can say that like tangent of theta just has to equal negative 1, right? And where does that happen? Right. No. Sine plus cosine has to be equal to 0, because that's how we factored this. Yes, but it can't be equal to 0, so this is the key thing here, Riley. X is not allowed to be 0, unfortunately. Right. Yeah. And so the only place that tangent equals negative 1 is going to be here. At negative pi over 4. Yes, exactly. It would be both. Okay. So, x, so what? Theta equals negative pi over 4. Right. Bada bing. Nice. Cool question. Yeah, the only issue is that sine cosine can never equal to 0, Rye. Because neither of these things can equal 0, because x can't equal 0 or pi over 2. Nice, Khaled. That was fun, though. It was fun, like, grouping. So this is always a great example of how, stuff you learn in algebra, right? Factoring. Comes into play into higher level courses. Like, this is like trig. Okay. Let's see. Next one. Got 14 minutes. I think we can get through them. To use Lagrange multipliers. I don't know. I don't remember Lagrange multipliers. Paul. Is Lagrange? I guess it is Calc 3, right? It's like Noether's theorem. Am I religious? I mean, I'm technically Catholic. I say I'll come back to it at some point. The whole religion thing. I believe there's definitely like a higher power. I don't know if it's a person or like someone that looks like Jesus, but there's definitely some guiding force. I don't think everything is random. Okay, sorry. Suppose f of x equals exy. Use Lagrange multipliers to find the extreme values of f subject to the constraint g of xy is x squared plus y squared is equal to 8. What? What are we saying here? I need to remember Lagrange multipliers. He says you don't need Lagrange.
Disqualified.
Did you want me to just plug this in? You want me to just say that, for instance, what is this? So y squared equals 8 minus x squared. And then just like substitute that in. Or wait, can I just do partial f, partial x, partial f, partial y? And then the extreme values are where that's equal to 0, maybe? Oh, it's e to the xy on a circle. It is on a circle. Oh, that's actually pretty cool. Radius 2 square root of 2. I see what you're saying. Okay, so the extreme values is where xy is max or xy is minimum. Ghost timer. Timer's right there. It's okay. Yeah, okay, cool. Oh, which will be symmetric, right? Because if I maximize it, for instance, right? If I maximize it here, yeah? Then e to the xy must be minimized here. Yeah, because e to the u is strictly increasing. Yeah, well, that's actually really cool. So, I think I can do this, right? X is equal to r cosine theta. We can parameterize this. Y equals r sine theta. So then xy is equal to r squared sine theta cosine theta. Yeah. And then I just need to do this d theta. I don't know what the Lagrange thing is, though. That's the issue. I think we don't need to do this with Lagrange. Yeah, and r squared is constant. R squared is equal to 8, right? So, and I think, isn't that something? What's sine cosine? Sine theta cosine theta? Well, that's kind of rude. It was 1/2 sine 2x.
Yeah.
Cool. Okay, so this is like u. So then to find the max, right? We just do du d theta. And that's going to be equal to 8 cosine 2 theta. Which is 0 at pi over 4. Which, okay, we already figured it out, right? So, yeah, okay. And I know from this, right? Yeah. You can also say that as well. Yeah, I guess we already know this is a maximum at pi over 2. Yeah, I mean, this is just like the extra step to it, but you don't need that. Okay, cool. So this is the max. And then this would be a min, right? And then this would be a max. And this would be a min. Disqualified. He says I find... Well, I think if we did it with the Lagrange multipliers, it might have been more fun. Okay. So, yeah, alright. And then sine and cosine is just square root of 2 over 2, right? So, the extreme values... So, okay. So, here... you have x is equal to it's square root of 8, right? Times square root of 2 over 2. Y equals square root of 8. Oh, so square root of 16, which is just 4. Oh, so just x equals 2, y equals 2. Oh, you're very welcome, Lucky Cat. So that's the max. And then the minimum is at -2, comma 2. Okay, cool. So the extreme values, that would be a legit 0 on exam.
Surprise, motherfucker.
Yeah. All right. I just don't know how to do Lagrange multipliers. Right. F of 2 is equal to e to the 4th. Sabotaging students.
No.
Oh no. E to the -4th. Okay, cool. Whatever. There's probably a legit way to do this with Lagrange multipliers, but I don't really have the time to do it. Alright, so this was Paul. But I think this is cool. I think this is still... I love the intuition of how this worked out. Okay, let's see what we got next. Vin. Nuclear bombardment. What's up, 1K? Good to see you, Berchacho. This is chemistry. Nucleide X is which of the following? So I think you have to have conservation of mass, right? So if this is 235 plus 1, I need this top thing to be 236. Right, and then this is charge. So this tells me right away this has to have a charge of 92 minus 55, which is equal to 37. And then yes, this has to be 236 minus 142, which is 94. Dude, it kind of counts as chemistry. Yeah. No, it's kind of chemistry. 9437. So wait, which one is that? That is rubidium. Nice, cool. Fun. Wait, 144? Wait, not 142? Okay. Ah, there's 3 of them.
Surprise, motherfucker.
Oh, I fucked up, dude. Yeah, you're right. Yeah, sorry. There's 3 of these. Damn. Okay. Yes. $92. D. D was the answer. Nice. Cool. That was Vin. Oh. Did I save this one? Sorry, let me save this one. Yeah, we forgot about the 3. Can't forget about the 3. Ooh. This is an interesting question. Let f be integrable on 0 to 1. Prove that the absolute value of f is integrable on 0 to 1. I'm pretty sure the 3 was just a suggestion. I don't know what the formal proof to this is. Let me look through real quick. If there's, dude, people posting Shrek pics again. God damn it. At least there's a delay between you posting Shrek pics. Ugh. Okay. Dane has a real question. Like that. All right, this is the last one. Last one for today. And then I gotta go. Compute the following integral. Ooh. Yeah, Zach, do you know how to prove integrability? I don't know how to prove it. I think I can do this one, though. Does this factor nicely? I feel like it does. No? They just kind of wrote it weird, right? This is like the same thing as negative x squared minus 4x plus 5? Yeah, why would you write it backwards like this? So I would pull out a negative 1. I agree with Zach here. And then that's just, yep. What multiplies to negative 5 but adds up to 4? 5 and negative 1, baby. So that's negative 1. X minus 5. X plus 1. Sorry, x minus 1. I don't actually, sorry. What am I doing here? Sorry. Wait. No. No, you're okay. X, there we go. That's what I meant. Yep, thanks, Zach. We2 says, I got a Calc 2-3 final in a couple days. Any tips before you leave for the weekend? Do as many practice problems as you can. Figure out like what things you're weak on, especially in Calc 3. I think a thing that really confuses students is like Green's theorem, Stokes' theorem, and like the divergence theorem, and like when to use them. There are some really great videos out there. I found this one woman. She was like, she got posted on my feed. What's her name? Professor V. Calc 3. Is that her name? Yeah, Math with Professor V. This is her. Yeah, she apparently has this. This is really cool, actually. I like all her videos here. These are a little long, so wait, let's go to like her. She had a cool one here on. Yes, here we go. This I think is a great video. It's a 30-second clip, so this is an example of her doing like, because dude, this stuff always messes me up, dude. Like divergence versus Stokes versus Green. I never know when to use which one. But where's the linked video of it? There's usually a linked video to it. Damn it, where is it? View products. I want to view your products. Just show me the next video. Oh, wait. I think once it ends, it'll tell me. No. Okay. Find it here. Here, this is it. Yeah. Full video on my video, Math with Professor V. I think this is where she does it. And it's a 2-minute video. I like this. So here, I'm gonna send this. Who asked this? You asked this in my Twitch? Yeah, there you go. This video I just watched like made a lot more sense for me when to use Greens and Stokes and whatever. Fundamental theorem of line integral. Yep, that's another really good one as well. Okay. So let's see if we can do this integral real quick. So this is the integral of 1 over to the 5 halves. 2 minutes equals 4 minutes. Yeah, I think I'm out of time technically, but it's okay. Oh, for that one. Yeah. Yeah, 2 minutes is 5. She's just putting arbitrary time things on stuff. Yeah, go check it out. Yeah, she has some good videos, actually. I do like her videos. I haven't made as many videos on Calc 3 yet. I probably should, because I've learned a lot of Calc 3 this quarter. She did something. I'm confused how she films her students though. Like, aren't there some rules against that? She does these videos. She's like, look at all the kids in my class. Look how fucking scared they are for this exam. I'm like, what? I don't think you can just like film people like that in your class. That's no bueno on the reels. Yeah, I agree, dude. Right? Yeah, wait, how do you integrate this? Because this has to be a square root, right? Down with Professor V. Okay, alright. I'm gonna send this in the Gemini real quick. Someone gave us a funny one. And then I gotta end the stream because I really gotta go. Sorry. Oh, I don't think it can do this one either. You might have to complete the square on the denominator. Yeah, complete the square. Okay. And then yeah, this is trig sub with sine. Oh man, this is a pain in the ass. Holy shit, this is a pain in the ass. Okay, we're not doing this one. Alright, I gotta end the stream. Alright, thank you everyone for coming to Actual Education Office Hours. Holy cardio, yeah, indeed. I need to do more cardio, honestly. That's the last stream for the week. We're gonna have another stream on Sunday. So if you guys got final exams coming up on Monday, come by. Let's help you out on the weekend. Best of luck if you have final exams tomorrow.
Good job.
Have a great weekend, everyone. Yep, exactly. And again, I implore you to, again, go check out our website, actualofficehours.com. Click on the streaming schedule, and you can see all the fun events that are happening. Zach will have a super fun Tournament of Champions round for his trivia game he's created called 16. And I am one of the champions. Will I be the champion? I don't know. I guess it depends if Femvox shows up. But come on by. That'll be fun. And then also, I guess he's doing a coding challenge on Saturday. I should check out the coding challenge. But the schedule for next week is as follows. I may change it just because we're getting towards the end of the year. And I have some other stuff I got to do. He is famous. He's on TV. If you're not already, make sure you go to the website and join our Discord. That's where all the questions get posted from today. If I didn't get to your question today and it's in the queue, do not worry. It will get added to our Discord, and one of our other awesome actual educator friends will probably donate some time and help you. Best of luck to all 16. Yeah, Femvox, I'm looking at you, dude.
Oh yeah.
Got you, Femvox, dude. Also, make sure go watch us on Twitch. Go give us a follow on Twitch. That is the best platform to watch. It is horizontal and all sorts of fun. And also, we're gonna go raid someone, which means we're gonna go say hi to another awesome streamer on Twitch. Okay, let's see. Who do we got? Who are we following? Who's on this Thursday? Let's see. Curly's playing video games. Science hats. Yes, you're very welcome. Okay, let's go say hi to Astro Canuck. Looks like he's doing something. He looks like he has a backyard telescope. Like, telescopes are dope. All right. Enjoy the rest of your week. Enjoy the weekend. We will see you on Sunday. Peace.